Hi, I'm Dr. Julie Brown, Carrick trained concussion doctor and board certified chiropractic neurologist. Today we're going to talk about the cerebellum, which is a magical part of the nervous system. I mean, let's be real, what part is not magical? Our nervous system lets us integrate in the world, perceive the world. It's amazing. But the cerebellum in particular sits in the back of the head here, and it has more neurons than the rest of your cortex. And there's one sensory organ that has direct input into it, which is your vestibular system, which I talked about last time, link up in the corner here. And it has direct input into it. So that vestibular system plays a very strong role with it. All the sensory information goes to the cerebellum, though the cerebellum does not discriminate where the sensory is. So if I were to touch a patient's arm, it's the cerebellum that coordinates it to get there, but it doesn't delineate like that's the arm. The parietal lobe is talking to it and saying, hey, it's over here. And that's how you figure it out. It's very specific, our nervous system. The other thing the cerebellum does is it participates in motor. You can lose parts of the cerebellum, but not lose motor control. You still have strength, but you will lose coordination. That's one of the biggest things. And thirdly, the cerebellum deals with higher function, higher cognitive function, and you can have a deficit in that in motor learning if there's an injury in the cerebellum. So that's why we do so many cerebellar tests. This is why if you are being tested for a DUI, they're testing the cerebellum because alcohol loves to attack one of the lobes of the cerebellum. So I do a lot of those DUI tests in my office to just get an idea of the function of the cerebellum. And then we also look at the cerebellum, how it relates to balance, to touch localization, to motor control. There's so many things that we do with it. So here is an image of the brain cut in half. And you can see this is the frontal lobe, the basal ganglia, all of that stuff is in here, brain stem. Then we have this cerebellum here. And you see it's cut in the middle, and you see all these little divots kind of here. It looks like trees, and that's why it's called folia. And that is the part that develops as you grow as a child. So this is why moving, interacting with your kids, flipping, turning, wrestling, all of these things are so important to growing that cerebellum and making sure that coordination comes out. Then we go over here. This is a very pretty picture of the cerebellum. I couldn't find a picture that showed the deep cerebellar nuclei. We have 4 on each side. The most midline go down into the spinal cord, and the most on the lateral side here, these would be considered newly developed to humankind, and they crosstalk up to the opposite cortex. So they play a huge role in that coordination. But you see this pretty color purple, that's considered the anterior lobe. The green is the posterior lobe, and this orange is the floccular nodular lobe. Now, this anterior lobe, when I was talking about alcohol, it will affect this lobe, and this is going to relate to your legs. I couldn't find a schematic that was really great that shows your hands and coordination out here, your spines here, different eye movements. There's images that I couldn't find or legally use to show, but it's very specific here. People who love chiropractic usually, I would argue, have some sort of dysfunction in that cerebellum, and they respond well to chiropractic adjustments in particular. Chiropractic is more than the adjustment, but neurologically, this is a part that plays a role in it. So this anterior part, if you are a chronic drinker, you will get atrophy. So we can look at an MRI, and these areas will be shrunken and much smaller. So that's obviously one thing we don't want to do to our cerebellum. Now, this floccular nodular lobe is pretty awesome. It relates to the vestibular system and balance. We know this floccular part on the outside, and this is the nodulus. We know that smooth pursuits, for example, your ability to follow a target like this, we know that is affected, and that is part of this floccular nodular lobe. This nodulus allows you to cancel VORs, what it's called. So if I turn my head, I can keep my eyes on the camera here. And if I don't, the eyes will like pop off, and we don't want that. So when we do different tests, we'll do quick head turns and have people stare at a target. Do the eyes stay on the target? We can localize what part of the nervous system are not this cerebellum is not working. We can apply therapies to make them better. Sometimes it's not about just, flinging your head back and forth. It's what can we do? Can we add some optokinetic stimulation? What other parts of the brain can we use that also fire down into that floccular nodular lobe? The cerebellum also, the main purpose of that cerebellum is it wants to inhibit everything. These multi-layers in here I couldn't make a video on it. It's a lot of detail to how quickly these things go. But if I were to contract my arm and hold it, because there's no movement, I'm going to allow for what we call Purkinje inhibition. So all the neurons come down to that one of the nucleus that it's talking to and says, inhibit whatever information, it does not go out. We're going to keep it right here. So movement, this is why a lot of people like movement. When you move, you never allow for Purkinje inhibition. And this Purkinje inhibition is important. You can have degeneration in every one of these layers. We don't want that, but it controls movement. So when I reach out, my hand isn't, doing this motion. It's very controlled. So we want to, that motor coordination is very important to the cerebellum. Now back to the cerebellum. This is not a good picture, but there are three what we call pedicles. This is the brainstem. It sits just right above the brainstem. And in the brainstem, you have three different levels, and the cerebellum develops with the mid part of that brainstem. So they are like best friends. And we have these three different areas, and this inferior part is the one that has the direct pathways from the vestibular system. So we basically make a triangle with the brainstem, the cerebellum, and the vestibular system. So the vestibular system talks directly to the brainstem. It talks directly to the cerebellum. The cerebellum talks directly to the brainstem and to the vestibular system. So it's a fine-tuned, coordinated event. And in my office, I evaluate that definitely when it comes to concussion. The research shows that if that is out of sync, you're going to maladapt. If I jump forward and do any eye movements or frontal lobe activities, or I'm going to maladapt the person. I'm going to make the frontal lobe try to make up for what the vestibular system or the cerebellum may not be doing correctly. And you got to get those foundational things addressed first. Then we move forward to the frontal lobe. I think that's all I have for you today. If you have any questions, feel free to ask them in the comments and ask anything related to the nervous system concussion. I may not have the answer, but you might inspire me to make a video. And that's it. We'll talk to you soon.